Hey everyone, so in this video we're going to be talking about one more way to solve systems, and that's going to be using Gauss-Jordan Elimination. Essentially, this is the way to solve systems using a matrix. Right? So these first three are these steps. Right? Now that's not to say that there's only going to be 3 steps in all of them. The second step is going to be very long. But the first step is always going to be write the system as an augmented matrix. So just take all the coefficients, put those coefficients into a matrix. The second step, and this is going to be the really long step, is going to be to write the augmented matrix into reduced row echelon form, which is this right here, which I'll talk about in just a second, using matrix row operations. Right? And the last step will be, just as before, to write our answer as an ordered pair or an ordered triple, because we are going to get into some systems that now have 3 variables, which means instead of an ordered pair, x comma y, we'll need an ordered triple, x, y, z. Right? So let's go back to that second step, the reduced row echelon form. All right, the one that's shown is for 3 equations, but this is essentially the goal of this method. At the end, we want our matrix to look like this, with 1s in the diagonal, 0s above and below those 1s, and then over here is going to be our answer. Alright, and I'll show you how that works whenever we actually start the examples, but just keep in mind that this right here is what we're trying to turn our matrix into. Alright, now just as a reminder, we have 3 different row operations that we can use, and it depends on if we're wanting a 0 or if we're wanting a 1. So if we're trying to make a 1, then the row operations we can use are either swap. Now I use caution for swap. I'm going to say that you can only use this as your first move. Alright, so either you swap the very first thing you do, or you never swap at all during this process. You can technically use swaps later, but it's a very common mistake to swap and then accidentally lose progress because you swapped something that you may not should have. So in general, use it for your first move, that way you don't have to worry about that. Alright, well, if we can only use swap for our first move, then the second one that we can use to make a 1 is to multiply a row by a number. So that was the number times the row. So say number times row 1, that's how we can make a 1. Now to make a 0, that's when we multiply a row and add to another. So that was the row operation that looks something like a number times row 1 plus row 2 would replace row 2. Alright, so those are the 2 main moves that you're going to do. You're either going to multiply a row by a number, or multiply a row by a number and then add it to another row. Alright, So let's go ahead and get into this, and I'll explain as we go a little bit more about that goal that we're trying to achieve. So we're going to start just with two variables, two equations. So our goal is going to be changed just slightly. Our goal is going to look like this. All right, that's what we're wanting by the end. Now, in order to do this, we are going to do it in a pretty specific order. This is the order to do it in order to not accidentally step on your own foot and mess up something that you've already done. So the top left one, that's going to be our first step. Then we get the 0 underneath it. That will be our second step. Once we're done with the first column, we move on to the next column, and again we're going to start with the 1, and then we make our last 0. Alright, so in general, even when we go on to the matrices with 3 equations and 3 variables, we're going to go column by column, and in each column we're going to get the 1 first, and then we're going to make the zeros. Alright, so let's go ahead and try this out. So first thing we need to do is put this in an augmented matrix. So remember, to do that, we just take all of the coefficients. So -2, -5, align where the equals was, 43. Then it's going to be 1, 4, -32. Alright, so our first thing that we want to do is we want to turn this -2 up here into a 1. So in this case, since it is our first move, we see that there's a 1 underneath it, and we can just swap these two rows. Alright, so we're going to do row 1 swapped with row 2. So if we go ahead and swap them, it's going to be 1, 4, -32, and then -2, -5, 43. Alright, so that's our first one. We got that one done. Next up, we want to change this -2 into a 0. Alright, so here's the key to making a 0. First off, we need the opposite of -2. So remember when we did elimination, we talked about opposite numbers? Same number, opposite sign. Opposite of -2 would be +2. So we're going to write down +2. Next, the row that we want is going to be whichever row we have our 1 in. Right? So in our case, the one that we just made was up here in row 1. So we put row 1. Plus, this next row that we put is where we want our 0. Because this part gives us a 2, but we need to add it to our -2 in order for it to make a 0. So row 2, and that's going to replace row 2. Right? In general, to make a 0 like that, what we're trying to do is just the opposite number times your row with your 1 plus row where you want your 0, so row for 0 replaces that same exact thing, the row for 0. Alright, so opposite number, row where you have your 1, plus where you want the 0 replaces where you want the 0. Alright, so let's go ahead and do that operation. So I'm just going to do it over here with a little bit of scratch work. So we got 2 row 1 plus row 2. 2 times row 1 would be 2. 8, negative 64. Row 2 is just negative 2, negative 5, 43. Add those up and we get 0, 3, negative 21. And that's going to be our new row 2. So, row 1 didn't change at all. But row 2 is now 0, 3, negative 21. And that gets us that 0. Alright, next thing, if we look at this over here, we see that the third step is going to be to get a 1 in that second column. So we want to turn this 3 into a 1. Well, how can we do that? Well, remember, we have to multiply by something. So if we want to turn a 3 into a 1, all we really need to do is multiply by 1/3. All right, because if you have a 3 and you divide by 3, you get 1. So it's 1/3 times row 2, because that's where the 3 is. We'll replace row 2. So again, I'm just going to do some scratch work over here to the side. So we got 1/3 times row 1, which was 0, 3, negative 21. Remember, this really just means that we're dividing by 3. So if we divide all of these by 3, we get 0, 1, negative 7. That's going to be our new row 2. Alright, so we have 1, 4, negative 32. The top row did not change. And for our second row, we're going to have 0, 1, negative 7. Alright, last step. We need to change this 4 into a 0. So we're going to follow this little rule down here. We need the opposite number. So that's negative 4. Which row has our 1 in it now? Well, we're working in the second column, so our 1 was right here. That was row 2. So row 2 plus, where do we want our 0? We want our 0 up in row 1 right now, and it's going to replace row 1. Just a reminder, these last two should always match. Those two rows should always be the same row. Alright, so in my recording space, I'm out of room, so I'm just going to go ahead and erase some of this real quick. Now I have a little bit of room again, so we can do this little scratch work. So it's going to be negative 4, row 2, plus row 1. Negative 4 times row 2 would be 0, negative 4, negative 28. Row 1 is 1, 4, negative 32. Sorry, that should have been positive 28, because negative 4 times negative 7 would be positive. So positive 28 right there. Then we can just add them up. So if we add them up, we get 1, 0, -4. All right, let's go ahead and put that back into our matrix. So our new row 1 is 1, 0, -4. Row 2 didn't change, so 0, 1, -7. All right, once we're here, all we have to do now is write our answer. Because remember, this column was representing x, this column was representing y. So what this is actually saying now is x equals -4. Y equals -7. It just gives us our answer on the right. All right, so x is -4, y is -7. Put that in our ordered pair, and we're done. All right, let's try another one of these. So again, we're going to start off by putting an augmented matrix. So 1, 2, -3, -2, -4, 6. We already have the 1 in the top left, so we can go ahead and make the one underneath it a 0 now. All right, so if we want to make that one a 0, then we're going to do 2, which let me get a different color, 2, because that's the opposite number, times row 1, because that's where our 1 is, plus row 2, because that's where we want to make the 0, replaces row 2 because those second ones always match. All right, so we got 2 row 1 plus row 2. 2 times row 1 would be 2, 4, -6. Row 2 is -2, -4, +6. Then we add those up. So we get 0, 0, 0. All right, so let's plug that in, because remember that is our new row 2. So we got 1, 2, -3, 0, 0, 0. Now, anytime you have all zeros in a row, then that is essentially saying 0 equals 0, which is true. So this one's going to be infinitely many solutions. And now, just as a side note, if our last row was something like 0, 0, 5, if this was our last row of our matrix, then instead of infinitely many solutions, this one's saying 0 equals 5. That's false, and so that would have been no solution. All right, so all zeros, infinitely many. All zeros, but then a different number in the last column, no solution. All right, so I'm going to go ahead and stop this one here. And then in the next video, we're going to take a look at some with 3 variables and 3 equations. It's the same process, just longer. All right, so still making ones and zeros though. So make sure you're comfortable with how to make a 1, how to make a 0, because that's going to be really important. All right, so right about now, you should see the card pop up. That'll take you to the next video, and I will see you there. Bye, guys.